Top Secret. Psi Operative Training Mission. Reading Passage. Mixtures and the Tyndall Effect. Mission. Understand the properties of mixtures and how to identify colloids. Tips. Remember to beam as you read through the passage below. I don't know if we're going to be able to make it all the way to the hive base, Dr. Nobel. The fog is making it impossible to see.
I better pull over, Zia. We won't be able to see until the fog clears.
Can't you just turn the bright headlights on? That would make it easier to see.
That will actually make it worse. The light will bounce off all the microscopic droplets of water in the air. You see, fog is actually a heterogeneous mixture, meaning that the parts of the mixture are unevenly dispersed and easily distinguishable. Even though you can't see the water droplets in the air with your eyes, you can easily see them using a microscope. Turning on the brights will only make more light scatter, making it harder to see.
If that's true, why do headlights normally help you see if water vapor is always there?
Well, the atmosphere is normally an example of a homogeneous mixture, one where the component parts are indistinguishable even under a microscope from each other. This is because air is made up of many different gases, all of which are mixed together evenly. These gases move around as individual molecules and atoms, not chemically combining with each other under standard conditions. Water vapor is just one of those molecules, moving around the air freely as a gas. That's why you can't normally see your headlight beams.
Oh, so if I looked at fog under a microscope, I could see the tiny water droplets? However, if I looked at regular air under a microscope, then the water vapor would be invisible? The image of fog shows water droplets of varying size making up the fog.
Right, Zia. Fog is actually a special kind of heterogeneous mixture called a colloid. These form when tiny little particles, smaller than our eyes can distinguish, indefinitely suspend themselves in a mixture. Milk, house paint, and wildfire smoke are good examples of colloids. While colloids may appear evenly mixed to the naked eye, if you were to view them under a microscope, you would see the particles are unevenly mixed. In the case of fog, these tiny water droplets scatter the light, making the light beam from our headlights visible.
As seen in the image, in a solution, a beam of light passes straight through. In a colloid, a beam of light scatters. Why would this be bad?
Well, when that light scatters, some of it will be bounced back our way, making it harder to see what is in front of us. This scattering will also keep the light from passing through the fog, illuminating a smaller area. Using the low beams keeps the extra light from reflecting back into our eyes.
How can you tell if something is a colloid? Is there a test you can do?
Yes, there is. We are doing one of the tests now with the headlights. You take a flashlight or other light source and shine it through the sample. If you cannot see the light beam in the sample, the particles are too small to scatter the light and the sample is a homogeneous mixture or solution. If you can see the light beam in the sample, then that means the particles are large enough to scatter the incoming light. This means that the sample is a colloid. This scattering of light by particles in mixtures is called the Tyndall Effect.
Shown in the graphic, when shining a flashlight, light is invisible when particles are evenly dissolved. Light is visible when particles are suspended. You said that the particles in a homogeneous mixture can't be seen, and in a heterogeneous mixture, they can be seen. What kinds of sizes are we talking about?
That is an excellent question. Take a look at this.
Comparing particle size. Solution. The particle size is 0.01 to 1 nanometer in diameter. Colloid. The particle size ranges from 1 nanometer and 0.1 micrometer in diameter. I want to see what happens when we meet with the hive in battle, and I try out my upgraded EMAG gadget. They won't stand a chance against me. It looks like the fog is clearing. Let's go find some aliens. Make connections. In each box below, write a connection between the text that you just read and either your prior knowledge or something in your life. Reading comprehension questions. Mixtures and the Tyndall Effect. 1. Fill in the Venn diagram below to compare and contrast homogeneous and heterogeneous mixtures. Homogeneous, both. Heterogeneous. 2. For each of the following, identify if a solution, colloid, and/or suspension is being described. A. It has particles 1 nanometer to 0.1 micrometer in size. B. It is a homogeneous mixture. C. It causes the Tyndall effect. 3. Explain why car headlights provide more assistance on a clear night than on a night with fog. In your explanation, include the terms homogeneous mixture, solution, colloid, and Tyndall effect. 4. The table below shows experimental results for 2 samples of mixtures. Based on the results provided, write in the particle size range in the last column. The table below reads Sample 1, laser beam visible, particle size, mixed type colloid. Sample 2, laser beam not visible, particle size, mixed type solution.